Good morning, students. Today topic is turbine speed governing system. So, turbine speed governing system. Actually, in power system, the power will be constant. So, the power will be constant and frequency also will be constant. Okay. So, uh, actually, the frequency will be constant. So, when we will maintain the frequency will be constant means by using the output power. Whenever we Whenever the output power will be maintained constant, the frequency also will be maintained constant. So the frequency and power are directly proportional, and it is directly proportional to speed also. Whenever speed will be changes, the frequency also changes because ns equal to 120 f by p. Okay, so actually here we want to maintain frequency will be constant. So by using speed governing system, we have to maintain the frequency will be constant. Okay, so here we have so this is a schematic diagram of speed governing system. So here we have speed governor. Okay, fly ball speed governor, and this is hydraulic amplifier, and this is speed changer. So this speed governor. So this speed governor will be heart of the heart of the governing system. That means the main so the main process will be done in the speed governor. Why? Because so it will detect the change in speed. Okay, so it will detect this change in speed. So whenever change in speed we will detect it, then change in frequency also will be detected. So so this is heart of the system. Here we have mechanisms will be there, A, B, C mechanism and C, D, E mechanism. Okay, so at first we have to see fly, fly ball speed governor. So these two are fly balls. So whenever the frequency will be increased, so the frequency will be increased, this fly ball will move outwards. So the fly ball will move outwards means it will be the fly ball will be moves outwards, and this this B mechanism will comes down. So it will comes down, and so whenever it will comes down, then speed will be changing. So the speed will be rises. So whenever the frequency will be increasing, the speed also will be increased. So the speed changer moves downwards. The speed changer will be moves downwards. And coming to hydraulic amplifier, coming to hydraulic amplifier. So here we have main piston, pilot valve, and high pressure oil. Okay, so hydraulic amplifier means we are using some high pressure oil or gas also we are using, but here we are using high pressure oil. Okay, so we are using high pressure oil. So speed control mechanism means that means it controls the speed of a steam. It controls the speed of a steam actually. So here the main two parts will be there. One is pilot valve and second one is main piston. Okay, so here main piston and pilot valve will be there. Hydraulic amplifier means it amplifies low low power pilot valve to high power high power pilot valve. Why why it will be seen here? So here we have to see. So this and so here this pilot valve will be closes this part. So whenever it will be closing this part, so whenever the frequency will be down, then speed changer will be goes up. Whenever the speed changer will goes up, then this pilot valve will move upwards. Whenever the pilot valve will move upwards, it will be open. Then this then this wall will goes through this, and it moves the main piston will be upwards. So the main piston will be upwards. So here this is a steam flow. So here the steam flow will be goes through turbine. So this uh, whenever this valve will goes up, then main piston, then this pilot valve will moves through this, and uh, uh, and it will uh, ups, the main piston will ups, and it will be closes here steam flow. So the flow of steam will be decreasing. Okay, so whenever the speed changer will be rising, so it means the speed will be increasing, the main piston will comes down. So and its main, and this valve will be comes down. So the steam flow will, the speed of a steam flow will be goes on increasing when flow of steam increasing, and then turbine output will also increasing. So this is a turbine also increasing, and these are um, um, two mechanisms will be there. First one is ABC mechanism and CDE mechanism, and the lengths are L1, L2, L3, and L4. So direction of the so the so the movement of direction will be comes downwards, and it is a positive direction. So so we had to discuss speed governor. So speed governor means this is a fly ball type speed governor, and it contributes the heart of the system, and it sends the change in the speed or a change in frequency. Why? Because when frequency and speed are directly proportional. With increasing a speed, the fly ball will move. So whenever speed increases, the fly ball will move outwards, and the point B and linkaging mechanism moves downwards or vice versa. So linkage mechanisms are ABC and CDA are a rigid links provided at B and D is respectively. So the mechanism provides a movement to be control valve in the proportional to change in the speed. So in link 4 provides a feedback from the steam valve movement. Okay, so hydraulic amplifier means this consists of main piston and pilot valve. Low power level pilot valve movement is converted into high power level position valve movement, which is necessary to open or close the steam valve against a high pressure steam. And speed changer. So speed changer provides a steady state power output setting for a turbine. The downward movement of a speed changer opens to the upper pilot valve. So upper pilot valve, so that more steam is admitted to turbine under the steady state condition. So the reverse happens when the speed changer is moves downwards. Okay, and next, mathematical model of speed governing system. So let initial values, frequency of a system is f naught. So the generator output will be pg naught. So here steam valve setting x naught e. Let the speed changer is lowered down by an amount of delta xa, as a result of a change in power will be delta c. So actually that's so here the speed will be changes, then amount of power will be also changing. So whenever the amount of speed changer will be delta x, then the resulting change in power will be delta pc. So then delta xa equal to k into delta pc. So the two factor contributes to the movement of at c. Here in the speed governing system at point c. So here at point c, here we have, so here we have two factor will be contributes. First one is increase in frequency causes B to move by a delta xb, then the frequency changes by a delta f, then the fly ball will move outwards, and B is lowered and by a delta xb, therefore this contribution is positive, and it is given by k1 delta f. Okay, So next, the lowering of speed changer by an amount of delta x lift the point c upwards by an portion of 2 delta x that leads to be k2 delta x or k2 delta pc. Here delta x equal to k1 delta f minus k2 delta pc. Okay, so here the speed changer equal to k1 delta f and minus k2 delta pc, where k1 k2 are constant. The moment of point D contributes by the moment of C and E. Since C and me move downwards, then the D moves upwards. Therefore, delta XD equal to K3 delta XC plus K4 delta XC when it is considered as the equation 2. So, assuming that the oil flow in the hydraulic cylinder portion is position of delta XD of the pilot valve, the value of delta XE is given by uh, delta XE equal to minus KF into integral of 0 to t delta XD dt. Taking Laplace transform for equation 1, 2, 3, delta XE equal to K1 delta F minus K2 delta PC of S. This is equation number 4. And delta XD equal to K3 into delta XC of S plus K4 into delta XC of S. That is equation number 5. Then delta XC of S equal to minus K5 by S delta XD of S. That is equation number 6. So substitute in equation, substitute 5 in 6. We get delta XC of S equal to minus KF by S, K3 into delta XC of S plus K4 into delta XC of S. Substituting equation 4 in above equation, delta XC of S equal to minus K5 by S, K3 into K1 delta F of S minus K2 into delta PC of S plus K4 into delta XC of S. Here delta XC of S equal to minus K5 by S, K3 K1 delta F of S minus K3 K2 delta PC of S plus K4 delta XC of S. Delta XC of S into S by K5 equal to K3 K1 delta F of S minus K3 K2 delta PC of S plus K4 delta XC of S. Okay. And next delta XC of S equal delta XC of S into S by K5 plus K4, that implies K3 K2 delta PC of S minus K3 K1 delta F of S. Delta XC of S equal to K3 K2 delta PC of S minus K3 K1 delta F of S, that is dividing by when it 1 plus 1 plus S by, here we are taking a K4 will be common, and it will be sending to right side. Then 1 plus S by K5 K4, and delta XC of S equal to K plus K divided by 1 plus ST into delta PC of S minus delta F of S, where K3 K2 by K4 is the gain of a speed governor, T equal to 1 by KF, K4 is a time constant of a speed governor, and R equal to K2 by K1. So black diagram representation of speed governor. So by using this equation, we are representing a black diagram. Here delta PC, and here this is a speed changer and this is a frequency changer. Whenever speed change kg by 1 plus stg, delta xc of s and delta f of s equal to 1 by r. This will be taking 1 by r minus and 1. So here kg by 1 plus stg, kg by 1 plus stg. This will be taken, and delta pc. So delta pc here, delta pc equal to, here delta pc equal to kg by 1 plus stg minus 1 by r. This is a black diagram representation of speed governing system. And next, turbine model. The model requires a relation between the the model requires a relation between the change in power output of a steam turbine to the change in its steam value opening of delta Xe. We consider here non-reheat turbine. Non-reheat turbine with a single gain factor KT and a single time constant TT, and thus in the crudest model representation of turbine, the transfer function is given as GT of S equal to delta PT of S divided by delta XC of S. That implies here we have KT by 1 plus STT. Typically, the time constant in TT lies in the range of 0.2 to 2 seconds. Shows the linear jet model and non-reheat turbine controller, including the speed governing mechanism. Okay, so this is a black diagram representation of turbine model. Kg by 1 plus STGE and delta XC by KT by 1 plus STT. Okay, and this is will be 1 by R. So output of delta PC of S equal to. So thank you. So today we discussed speed governing system and turbine model. Okay. Next we will discuss the remaining topics.